So this video is going to go over every answer specifically. If you don't need to hear the explanations and you just want to check the answers, go ahead and look for that uploaded PDF document rather than watching the video. So I'm just going to go ahead and talk out loud while I do all the answers 1 through 10. So we start with number 1. That's just kind of our example problem. That's our go-to. When I see an exponent, we know that an exponent means how many boxes we're supposed to write. So since the exponent here was 3, we are going to make 3 boxes. And then in those boxes is whatever the exponent applies to. So right next to it is a 5. So in each of those boxes, I'm going to put a 5. And then as we know, exponential functions are always multiplication. So I'm making sure to emphasize that those boxes are connected through multiplication. Now, when we look at number 2, this is where things get a little bit harder. We can see that there is an exponent of 3. So I'm going to go ahead and put 3 boxes. However, when I look at what this exponent applies to, it's directly next to the 5. It can only reach the 5. It cannot reach the negative. If the negative wanted to apply, I would have had to have used parentheses. So the negative doesn't go in the boxes. Only the 5 does. So again, we can kind of compare those answers. So this would be our final answer there. Or you could write it as -5 times 5 times 5. When I look at number 3, I can see an exponent of 3, so I know somewhere in my answer I'm going to have 3 boxes connected by multiplication. Now that 3 has short arms. It can only attach to what it's directly next to. It's directly next to the x, so the x is what's going to go in each box, which means that 4 wasn't part of the exponent. It was just in front of the exponent. So this would be our final answer there. Or you could write it again as 4 times x times x times x. Now in example number 4 itself, what I see is there is an exponent of 2. So I know that I'm going to have 2 boxes. But in this case, I can see that the exponent has some helper. It has some parentheses there. So when it reaches out to grab something, it grabs onto the parentheses. So everything in the parentheses is what's being squared. So this would be 4x in each of the boxes, which would just be 4x times 4x. Either one of those is fine for your answer. Now, when I look at number 5, what I can see is there is an exponent of 0. So I'm not going to draw any boxes, no boxes at all. And the thing is that exponent applies just to the 10. So in other words, this little negative is going to be there, and I'm drawing no boxes. So if I don't draw any boxes, a negative is really just the number -1. Compared to number 6, I do see that same exponent of 0, so I'm not going to draw any boxes. But the idea here is that 0 is next to a set of parentheses, so everything in there would be in the box. So anything to the 0 power is just going to be the answer of 1. In number 7, I can see that there is an exponent of 3, which means I'm going to have 3 boxes. And then since that 3 is directly next to the parentheses, whatever's inside the parentheses goes in the boxes, so -5. Or you could just write it as -5 times -5 times -5. Now over on number 8, again, I do see that there are going to be 3 boxes because the exponent is a 3. But in these 3 boxes, because that 3 is only next to the 5, it can't reach over to the negative. If it needed to reach the negative, it needed its parentheses as helpers, which means that only the 5 is going to go in each box. And that little negative sign was just out front of the boxes. So you could write it as -5 times 5. Now, number 9, I see an exponent of 3. So I know that I'm going to have to make 3 boxes. And since that 3 is next to a set of parentheses, when it grabs those parentheses, I see that the base is -3. Which means this -4 here was just being multiplied by whatever that thing was. So this -4 would just go in front of all those boxes. Same thing with number 10. I do see an exponent of 2. So I'm going to draw 2 boxes. Now in those boxes, I look to see what the exponent applies to. So it's right next to a set of parentheses, so it applied to the 4 and the x. But it can't reach the negative. If it wanted the negative would have been inside those parentheses, so that negative's just going to be out front. And that'd be your final answer. So this video will go over As we're thinking about these, we need to keep track of our negative exponents, and we know negative exponents move, but we got to keep track of what that exponent is actually applying to. So here I can see the exponent of -3, and the only thing it's directly next to is the y. If it wanted to get the x, it would have had to have used those helper hands like those parentheses. So just the y is going to move, which means nothing else is moving. So the x squared was staying on top. There was a 4 on the bottom. And since we're doing exponentials, when I move those y's to the bottom, we connect it with multiplication. And we know the negative told us to move, so once I move it, I get rid of the negative. So in number 2 here, again, I see a negative exponent. So that negative exponent is only going to apply to what it's directly next to. It can't reach the 4. If it wanted to reach the 4, it would have need to have used parentheses. So when I simplify this, the 4 is going to stay on top where it was. The 3 is going to stay on the bottom where it was. But those x's, 2 of those x's, are no longer going to stay on top. The negative tells us to move those x's to the bottom, and after I move them, there's still 2 of them. So after I move it, the exponent, or the negative, goes away. Now in question number 3, I see there's a -2 as my exponent. So the negative exponent tells me to move. So whatever the 2 is applying to, and since it's next to parentheses, the entire thing is going to move because the entire thing gets the negative. So the 3 was already on the bottom, but then in parentheses, 4x would have moved there, and there was 2 of them. Now, as we know, if I remove everything from the top, I replace it with the number 1. In number 4, I can see the negative exponent. So something's going to move, and that negative exponent is directly next to the 10. Not the negative, just the 10. So only that 10 is going to move, which means the negative is going to stay on top. The 3 was going to stay on the bottom, but now the 10 moves to the bottom, and instead of being a negative, since we already moved it, the exponent now is just regular 3. And again, if we remove all the numbers, the number on top is a 1. And again, pay particular attention that I'm connecting them with multiplication, because we know exponential properties or exponential functions are all about multiplication. In number 5, I can see that there's a negative exponent and it's directly next to the x. So the x started on the bottom, but the negative exponent is going to tell it to move to the top. So there already was a 6 on the top. These x's are going to move to the top, and there were 6 of them. If I remove everything from the bottom, I replace it with a 1. And we don't need to divide by 1, so either one of these would be fine. In number 6, I can see 2 sets of negative exponents. This -6 is directly next to the x, which is going to tell me to take that x and move it to the bottom. Now over here, the y's were also a negative exponent. So that -3 is going to tell me to take that base of y and move it to the top. And after I move it, I no longer need the negative, because I don't need to move it again. The final one on number 7 is we can see that there is an exponent there, but that exponent of -6 is only next to the x. So only the x is going to move. If I wanted it to move the 3 as well, I would have need to have used parentheses. So that 3 is not going to move anywhere because it doesn't have an exponent, but the x's are going to move to the bottom, and there's going to be 6 of them. Now originally on the bottom, I can see that there was this negative exponent, and it's next to a set of parentheses. So everything in that parentheses is going to move to the top. So if I'm adding another thing to the top with exponentials, I connect it with multiplication. So I leave the number -2 in parentheses, and if it moved, there's going to be 3 of them up top now. And the final one, I can see that this entire base here, because of the negative, would move to the bottom. So in there I have 3x. And then after I move it, it becomes a 6. I no longer need the negative because the negative told me to move. Now on the bottom, this is probably the most complex one, is I can see there's a negative exponent. But that negative exponent is only directly next to the 2. It can't reach the negative. So only the 2 is going to move to the top, which means that little negative is just going to stay on the bottom.